Hi everyone, for today's lesson we are going to learn how to graph and write equations of ellipses. And what an ellipse looks like is it looks like an oval. So we're going to be graphing shapes that will either look like an elongated oval that is like horizontal or vertical. And depending on whether it's horizontal or vertical, just depends on the kind of numbers that we are given and where those numbers are located. But before we get started about actually exploring and graphing ellipses, I would like you to please go ahead and do this really quick warm-up in which I would like you to please multiply these two fractions together. The first fraction is going to be x plus 3 divided by x cubed plus 5x squared plus 6x times x to the fourth power plus x cubed minus 2x squared divided by x squared minus 1. So this is a problem that we talked about at the very beginning of this semester, and like I said to you guys before, our final exam is coming up pretty quickly, so I want to make sure that I talk about some of these topics again. So go ahead and pause the video and multiply these two fractions together, making sure that you cancel out any common factors in the numerator and the denominator. And when you're finished, go ahead and restart the video and we'll see how well you did. All right, so hopefully you were able to factor the denominator, and you were able to see that the denominator has in common an x, and you're left with x squared plus 5x plus 6. So I'm going to leave my numerator of x plus 3, and I'm going to divide it by x times, and I'm going to split up this quadratic into two parentheses, and that's going to be an x plus 2 and an x plus 3, and that's because 2 times 3 equals 6, and 2 plus 3 equals 5. Then I'm going to write times, and all of these terms have in common an x squared. The leftovers is going to be x squared plus x minus 2. And I'm going to factor that into two parentheses. So I'm going to break that down into two parentheses, splitting apart the x squared into an x and an x. And two numbers that when multiplied together that equal -2, but together add equal 1, or positive 1, are plus 2 and minus 1. And down here we have ourselves a difference of two squares. So I'm going to make that x plus 1 and x minus 1. Now that I have factored each expression, I'm going to eliminate anything that's the exact same on the top and the bottom. So I notice that I have an x plus 3 in the top and an x plus 3 in the bottom. I have an x squared and an x, so one of the x's will get eliminated and I'll be left with just one x into the numerator. And then I have an x plus 2 in the top and the bottom, and I have an x minus 1 in the top and the bottom. So the only thing I'm left with is x over x plus 1. And that is our answer, x over x plus 1. Hopefully you did pretty well with that. If you didn't, please feel free to email me or stay after class sometime, and we can certainly talk about how to multiply these types of fractions. So now let's go ahead and talk about the equation of an ellipse. Let's go ahead and start off by talking about what the general equation looks like. So the general equation of an ellipse looks like x squared over a squared plus y squared over b squared equals 1. That's your general equation. And that's where, just like we did when we were graphing circles, if you do not see a plus or an H and a K, then that means that your center is going to be your center is going to be located at 0, 0. So in this case, our center is going to be located at 0, 0 in this general form, in the general form. But if you look at the equation that I gave you, unfortunately, this equation is not equal to 1, and it must be equal to 1. So what I'm going to do first is I'm going to divide 100 on each side, and what that's going to do is it's going to make my equation now equal to 1. And I know that 25 divided by 100, that's going to be equal to x squared over 4 plus 4 over 100 is going to be y squared over 25, and this is now equal to 1. So now this is written in the form that I want. So now the question is, whenever we are, well, obviously in this case, the center is going to be 0, 0. So now I showed you that there are going to be two different shapes that we're going to be graphing. It's either going to be horizontal or it's going to be vertical. And the horizontal axis, if your graph is supposed to look like this, your horizontal axis would be considered our major axes. Or if your your ellipse looks like this, then that means that your y-axis would be your major axes. And the way to tell which letter or which axis is going to be your major axis is to simply look for the largest denominator. Looking at our denominator, clearly 25 is bigger than 4. 25 is below y. So therefore, our major axis is the y-axis. So we know that our ellipse or our oval shape is going to look just like this because our major axis is the y-axis. 25 is bigger. So in order for us to figure out our vertices and co-vertices, the way to figure that out is it's going to be your A and B values. And so that's what below I have A squared and B squared. Don't worry about which one's A and which one's B. In general, we're going to have perfect square numbers underneath, or numbers that we're going to be taking square roots of underneath our x squared and y squared. And in this case, we're going to take the square root of 4 and we're going to end up with 2. And this is, I'm going to call that A, and the square root of 25, I'm going to call that B, and that's going to be 5. So I'm going to start by plotting 0, 0. And just like we did before, whenever we were working with a focus, we count a focus and directrix, we counted. We're going to be doing the exact same thing with this. So since the square root of 25 is 5, and 25 was below y, I'm going to count 5 units to the north and south of 0, 0. So I'm going to count 5 units. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So just like we did when we were graphing circles, we plotted points to the north, south, east, and west. We're going to do the same thing for ellipses. We're going to count points to the north, south, east, and west. So because 25 is below y squared, and the square root of 25 is 5, I'm counting 5 units to the north and south. Because 25 is below y squared, and this is our major axes, these 2 points would be considered our vertices. So they would be located at 5, 0 and -5, 0. These would represent our vertices. So this is a vertex. And this point right here would also be considered a vertex. So now A equaling 2, since 4 was below x squared, we're going to count starting at 0, 0 to the left and right along the x-axis. So I'm going to count 2 units to the right and 2 units to the left, 2 to the east, 2 to the west. And these 2 ordered pairs, they are located at 2, 0, and, I'm sorry, I messed up on this, excuse me. These ordered pairs are located at 0, -5, or 0, 5 and 0, -5, excuse me. So we have 0, 5 and 0, -5. And now my co-vertices are going to be located at 2, 0 and -2, 0. And these are called a co-vertex. So this is a co-vertex. Now we're almost done with drawing ellipses, but ellipses have foci. Foci means that it has more than one focus, and all ellipses will have two focuses that we call foci. So the focus, some things to note, the focus is always on the major axes, or the foci. are always on the major axes. And what the foci are, please note that all ellipses have two foci. So they have two foci. And what foci is that they are 2 points in which any point, if you were to take the distance that any point is from the two foci, add those distances together, you're going to end up with a constant value. So there's going to be 2 points that we're going to be plotting. And these 2 points represent, if you were to add the sum of the distances that any point is away from the foci is always the same. This information, I don't need you guys to memorize it. It's just background information so that you know where the foci came from. Fortunately, foci has its own formula. And since we conveniently use the letters A and B, I'm going to use the letter C in order to describe how to identify what your foci are. And since there are 2 of them, here is your equation. I'm going to call foci C. So we're going to call the foci C. So we call them C. All right. And the formula for foci is this. It's going to be that C is equal to plus or minus the square root of A squared minus B squared. Now, please note that the A and B doesn't matter. You might have, so I'm just assigning letters. It doesn't mean that A is always below X squared and B is always below Y squared. So when it comes to this formula, I need you to, because we're taking the square root of a number, that number that we take the square root of is always positive. So this is always positive. So interchange these 2 numbers as need be. So put 25 before you put 4, meaning something like that. So this value is always going to, underneath the square root, is always going to be positive. So interchange the A squared and B squared as needed. Meaning that in this case, 25 is bigger. So if we wanted to figure out what our foci are, I'm going to write that C is equal to plus or minus the square root. Our A squared is equal to 4 and our B squared is equal to 25. But like I said, we're going to interchange those. So I'm going to put 25 first, then minus 4 because I want my value under the square root to be a positive number. So C is going to be equal to plus or minus the square root of 21. But the square root of 21 is kind of tough to graph. So in this case, that's going to be approximately plus or minus 4.6. So that is where my foci are. And like I said to you before, foci are always located on the major axes. So what I'm going to do in order to find my ordered pair for my foci is I'm going to start at 0, 0, and I'm going to count 4.6 units to the north and to the south. So going to the north, I have 1, 2, 3, 4. 0.6 is about right here. Then I'm going to go to the south, 1, 2, 3, 4, and then just a little further than halfway, there's my other foci. So here are my 2 focus points. So my 2 foci, and those ordered pairs are located at 0, 4.6, and 0, negative 4.6. So 0, 4.6, and 0, negative 4.6. Those are your foci. Those are your ordered pairs for it. So now what I'm going to do is I'm just going to draw a smooth oval, smooth curve going through my vertex and co-vertexes, or my vertices and co-vertices. And there's your first picture. So once again, what you want to do is you want to identify which axis is going to be your major axes. Your major axes is going to be based on which fraction has the larger denominator. In this case, y squared had the larger denominator. Y-axis wins. Your center is going to be 0, 0 because there's no h and k that we can see yet. Our vertices are going to be based on the major axes. Our co-vertices are going to be based on the minor axes. So our minor axis is going to be the skinnier axes. The way to come up with how many you count is you take the square root of your denominators. The square root of 4 is 2. The square root of 25 is 5. So that's how you know what you're going to count. And in order to find what your foci is, you're going to take plus or minus the square root of your difference between your denominators, always making sure that you put the big one before the little one. So that's something that's important. And then your foci are always on your major axes. So that's how you graph an ellipse. Let's go ahead and look at example number 2. For example number 2, fortunately, this is written in the general form, which is awesome. Now, because 16 is bigger than 9 and 16 is below x squared, our major axis this time is going to be the x-axis. Our x-axis is going to be our winner. So this time around, we have a is equal to 4, that's the square root of 16, and b is going to be equal to the square root of 9, which is 3. So my center, fortunately, we're working with x squared, y squared. So my center, once again, is going to be located at 0, 0. We do not see an HK, so we're not going to worry about that yet. So I'm going to make this 0, 0. And starting at 0, 0, I'm going to count. Since 4 is located with x, I'm going to count 4 units to the left and right. 1, 2, 3, 4. 1, 2, 3, 4. And these points represent my vertices. So my vertices this time around are going to be located at 4, 0 and negative 4, 0. So this represents a vertex, and this represents a vertex. My co-vertice is where I'm going to start at 0, 0, and I'm going to count 3 units up and 3 units down. So I'm going to 1, 2, 3. And 1, 2, 3, and those ordered pairs are located at 0, 3 and 0, negative 3. And now I need to find my foci. So my foci, that's going to be equal to c equals plus or minus the square root of a squared minus b squared. But remember I said to just use these values and interchange them. It doesn't matter if A is first or B is first. You want large minus small. So my large square, 4 squared is 16. So C is going to be equal to the plus or minus of 16 minus 9. And 16 minus 9, that's equal to 7. So that C is equal to plus or minus the square root of 7. And square root of 7 is approximately 2.6. So this is plus or minus 2.6. Now, like I said to you before, foci are always on the major axes. So my major axis is the longest axis. So I'm going to count 2.6 units to the left and 2.6 units to the right. And these ordered pairs are going to be located at 2.60 and negative 2.60. So now that I have my foci graphed and my co-vertex or vertices graphed and my vertices graphed, I now have everything that I need in order to graph or draw my ellipse. And that is all you do. All right, so once again, foci are going to be on the x-axis because this time around, that is what our winner is. The x-axis is our winner. It's our major axis. All right, so now let's go ahead and change it up. This time around, I'm going to give you a center that's going to be a little bit different. So our general form this time around has been changed up to now include an h and a k. So our general form this time around is going to be x minus h squared all over a squared plus y minus k squared divided by b squared equals 1. This is my general form. And that's where my center is located at HK. And it's the opposite of what you see, just like we had in our circle lesson that we did last time. So let's go ahead and identify what our center is. Our center in this case is going to be the opposite of what we see. And the opposite of -2 is +2. And the opposite of -1 is +1. So 2, 1 is my center. Let's go ahead and identify which axis wins. Well, 16 is bigger than 9. 16 is below x. Our winner, the x-axis. That is our major axis. So we know that we're going to have a horizontal ellipse. So now I'm going to plot 2, 1. I'm going to go over to 2 and I'm going to go up 1. And now I need to figure out what I'm going to be counting. So the square root of 16, that is 4, and the square root of 9, that is 3. So I'm going to count I'm going to count horizontally 4 units. So starting at my center, I'm going to count to the right 4 units and to the left 4 units. And now starting from my center, I'm going to count vertically or up and down 3 units. 1, 2, 3, and 1, 2, 3. And I now need to identify what the ordered pairs are that I just plotted. So you can do it the old-fashioned way, where you count and you go, okay, I went over 2 and up, etc., etc. Or you can do it mathematically. So I know that with A, I went to the left and to the right 4 units. So what I would do is I would simply add 4 to my x value. So 2 plus 4 is 6. And this is certainly located at 1, 2, 3, 4, 5, 6, 1. So that's going to be my vertex, one of my vertexes or vertices. So that's going to be 6, 1. And then 2 minus 4 is -2. And this is certainly located at -2, 1. And that's just doing it mathematically in your brain, or you can just count it out. Whatever floats your boat is perfectly fine with me. But I want to make sure that you are aware of that pattern. So now the thing that changes here is our y value. So our co-vertices, our x value remains the same, but our y value is being increased by 3 and decreased by 3. So 1 plus 3 is 4, and this is certainly located at 2, 1, 2, 3, 4. And going 3 units down, we have 1 minus 3 is -2, and this is certainly located at 2, -2. Next, we need to identify what our foci are. So I'm going to write C is equal to plus or minus the square root of a squared minus b squared. So it's the large squared, so that's 16, minus our small square, which is 9. This equals plus or minus the square root of 7, and that is approximately plus or minus 2.6. So this time around, it's on the x-axis. And I'm going to count 2.6 units. So I'm going to go 1, 2, and this a little bit more. And then back, 1, 2, and just a little bit more. And in order for you to identify what those values are, I would just take the x value of your center and add 2.6 and subtract 2.6. So 2 plus 2.6 is 4.6, 1. And 2 minus 2.6 is equal to negative 0.6, comma 1. And that represents your ordered pairs for your foci. So now I'm going to draw a smooth curve going through all of my points. And there is my ellipse with my two foci. Okay, let's go ahead and look at example number 4. So for example number 4, let's go ahead and figure out which axis is going to be our winner. So for this problem, 36 is bigger than 16. 36 is below y. Y means that our major axis is the y-axis. So our y-axis is our major axis. So that means that we're going to have a vertical oval shape, a vertical ellipse. My a value is going to be equal to is the square root of 16, which is 4. My b value is the square root of 36, which is 6. My center is the opposite of what I see. And the opposite of a minus 4 is a positive 4. And the opposite of a positive 2 is a negative 2. Now, I'm here to tell you for this type of problem, based on counting and experience, what we're going to do is we're going to go by 2s for our x and y values. So we're going to go by 2s on our x-axis and our y-axis. So I'm going to count over 4, negative 2. So 2, 4, down to negative 2. So here is my center of the ellipse. And since B, or 6, was below y, my major axis is going to be where I'm going to count 6 units to the north and south, 6 units up and 6 units down. So I'm going to count 6 units going up. That's 2, 4, 6. And then 6 units going down, 2, 4, 6. And then my going horizontally, I'm going to count 4 units. 2, 4. And over here, I have 2, 4. So now we need to come up with what those ordered pairs are. And there's a shortcut and a long way. A long way is to actually kind of count. Short way is just to say, okay, 6 corresponded with y, negative 2 plus 6, that is equal to 4, so 4, 4. And negative 2 minus 6, that is negative 8, so 4, negative 8. For my covertices, that deals with my x values, so I'm going to take 4 and add 4, so that's going to be 8, negative 2. And I'm going to take 4 and subtract 4, and that's going to be 0, negative 2. And you're more than welcome to count and check, but those are going to be your vertices, your actual, not the actual points in which we count. Now, in order for us to find our focus, I'm going to write c is equal to plus or minus the square root. And I'm going to put my big number first, so my big denominator first, that's 36, minus my small denominator, which is 16. So this equals plus or minus the square root of 20. And the plus or minus the square root of 20 is approximately plus or minus 4.5. So since my major axis is the y-axis, my foci will be on the y-axis this time. So I'm going to count 4.5 units going up and going down. So that's 2, 4, and then a little bit. And then 2, 4, and then a little bit more. And so in order for me to identify what these points are, I'm going to simply take my y values and add and subtract 4.5. That's my y values of my center. So my y value of the center is negative 2. So negative 2 plus 4.5, that is equal to 2.5. So that is going to be located at 4, 2.5. And now I'm going to take my, my y value and subtract 4.5. So that's going to be negative 2 minus 4.5, which is negative 6.5. So this is located at 4, negative 6.5. And that's my top point and my bottom point. So this is located at 2, 2.5. And this is located at 2, negative 6.5. So 2, 4, 6, and then a little bit, 0.5. So now that I have all of my vertices plotted, my foci plotted, I'm just going to draw a smooth curve going through all of those points. and that is my ellipse. That is the end of today's lesson. If you have any questions over anything, as always, please feel free to email me. Otherwise, I hope you have a wonderful day.